Hi, this video has the solutions for the Chapter 4 review. Number 1, we're supposed to find dy dx if xy is equal to sine y. So this is an implicit differentiation problem. Can't forget the product rule here. This is x times y. That's probably the most common mistake in this kind of problem. So derivative of the first is 1 times the second. Derivative of the first is 1 times the second plus the first times the derivative of the second. That's that side. And the derivative of sine y is cosine y dy dx. That's probably the second most common mistake, to forget that that pops out. Every time we take the derivative of a y, a dy dx pops out. And then we just have to do a little bit of algebra to rearrange things here. So I'm going to subtract that over to the other side. And then factor out the dy dx. And divide, that gives me dy dx equal to y over cosine y minus x. If you had done the algebra differently, you could possibly end up with minus y and then have these the other way around. That would be equivalent to this. That would be also correct. Number 2. Now we're finding a second derivative, and starting with y squared plus x minus y equal to 3. So first derivative, 2y dy dx plus 1 minus dy dx equals, don't forget that that's going to go to 0, right? So moving things around, just to keep more positives than negatives, I'm going to move those things to the other side. So that gives me dy dx minus 2y dy dx is equal to 1. Right? You could have the signs all backwards here. And then factoring, I get dy dx. And dividing by, I'd have 1 minus 2y. I have that. And to avoid using the quotient rule, I think we're going to go ahead and write that like this. Okay, now we're finding the second derivative, so I'll take the derivative again. So the derivative of dy dx is the second derivative, and then the derivative of this would be minus 1 minus 2y to the minus 2 times the derivative of what's inside. There's nothing pops out yet because I haven't taken the derivative of a y yet, right? That's just the chain rule. Just taking the derivative of something to the minus 1. And then multiplying by the derivative of what's inside, that would be minus 2 dy dx. Right? Now I'm not done yet because I'm not supposed to leave this. So I'm going to consolidate the minus 1 here and the minus 2 here. It gives me a positive 2. And then I have 1 minus 2y to the negative 2 times dy dx, which is 1 minus 2y to the negative 1. And I suppose in free response you could leave it like that, but we could consolidate those and say that that was equal to that. Or again, equivalently, could write it like that. Oh, there you go. Number 3. We're supposed to find both tangent lines to the curve y squared plus xy plus x squared is equal to 3 at the point where x equals 1. Or it could be points where x equals 1, right? Because these implicitly defined curves are usually not functions. So I'm going to go ahead and find those points first by plugging 1 into this. That gives me y squared plus y plus 1 equals 3, or y squared plus y minus 2 equals 0, or y minus 1 is y plus 2 equals 0. So there are in fact 2 points. So my points are 1 comma 1 and 1 comma negative 2, right? The same x value of 1 led to 2 different y values. So these are my 2 points. Okay, now I need to find the slope at each one of those points. So I'll find the derivative. That's 2y dy dx plus, and then the derivative of this product, derivative of the first times the second, plus the first times the derivative of the second, plus 2x equals 0. And then consolidate and move stuff. I'm going to do that in one step, if you will permit me to do that. So the terms that would be moved to the other side, that would be minus 2x minus y over here. And then when I factor out the dy dx, I have to divide by 2y plus x. You can check those steps. Now I need to find the slopes at each of these 2 points. So I'm going to borrow the notation that our book uses sometimes. So dy dx at the point